Hi, welcome to Section 2-3 Notes. This is titled Biconditionals. So we're still in Chapter 2 with logic, going over logic and reasoning. In Section 2-1, we talked about sequences and patterns in direct reasoning. In Section 2-2, we started talking about conditionals and if-then statements, conjectures, counterexamples, and so forth. And so now this is a biconditional. So if you think of what we've already talked about with conditionals, conditional is an if-then statement, but now it has by in front. Try and think of what that prefix by means, like bicycle. And hopefully you're thinking of to. And so that'll be a good reminder of what a biconditional is. So a biconditional is a single statement that combines a true conditional and its true converse with the words if and only if. If and only if. And someone came up with this little abbreviation, IFF. I think it looks a little weird, like a misspelling or something. So I don't usually use it, but if you would like to use it, that's a legitimate thing that you can use if you want, instead of writing out the words if and only if. Okay, in symbols, a biconditional combines our original conditional, like we talked about in section 2.2, if P, then Q, where again, P is representing our hypothesis and our Q is representing our conclusion. And that arrow means it's an if-then statement. And our converse, which we talked about in section 2.2, that we write if Q, then P. We've switched the hypothesis and conclusion around. It's still an if-then statement. And so again, a biconditional combines the conditional and its converse as, we're going to write P and then double arrow Q. And that's what our symbol is for a biconditional. I'm going to put a little box around that with red. So that is what our biconditional is. And again, what that means is P if and only if Q. I'm going to write that underneath. Okay, so that's what we're going to go over a little more about, an example of biconditional and that kind of thing. But again, P if and only if Q is what that is referring to. So let me move this up a little bit. It says in example 1, it says, write the converse of the true conditional. If the converse is also true, rewrite the statements as a biconditional. Okay, so the original conditional says if the sum of the measures of the two angles is 180, then the two angles are supplementary. So again, I like to just write little reminders for myself. I know this conditional is if P, then Q. It doesn't look like a Q. So then I know that the converse of that needs to be Q, then P. And I want to fix this Q because it doesn't look very good. There we go, that's better. Okay, so if I go ahead and write the converse, then I can say that if two angles are supplementary, I'm going to abbreviate angles. So if two angles are supplementary, then the sum of the measures of the two angles is 180 degrees. Okay, and again, if we look back at the directions, it said write the converse, which we just did. It already told us that our conditional was true, it said of the true conditional. So they told us that's true, but if we read it, if the sum of the measures, two angles is 180, then the two angles are supplementary, we can tell that as a true statement. It says if the converse is also true, rewrite the statement as a biconditional. So we need to check that. We need to see if this converse is a true statement. So if we read that, if two angles are supplementary, then the sum of the measures of the two angles is 180. So that is a true statement. So I'm going to go ahead and write true. And because I got a true here and because I got a true here, then that means I'm allowed to write a biconditional. If I write a biconditional, whose symbol is again if P double arrow Q, so P if and only if Q, then that means that we're basically going to take the if and then out of the sentence and put if and only if in the middle. And we can technically do that to the conditional or the converse. Either is fine. I generally just go back to the original conditional to do that. So if I show you in purple what we're doing, we are technically going to take this if out. We're technically going to take this then out. And we're technically going to, right in the middle here, write the words if and only if. Here, I'll put our little abbreviation. Okay, so that's all we're doing. So I just need to get it written out. So the sum of the measures of the two angles is 180 if and only if the two angles are supplementary. I'm just going to abbreviate that as SUPP. Okay, so again, a biconditional, just taking the if and then out, putting if and only if in the middle, and technically can be in either order because they would both be true. Okay, if we go and move that up and look at another example, it says, what are the two conditional statements that form this biconditional? So here we're just working backwards from what we just did. In this one, they gave me the biconditional, the if P double arrow Q. And so it's kind of strange. This confuses people when it asks for the two conditionals. Sometimes people write the same sentence twice, but technically a conditional in general form is just an if-then statement. So technically they're wanting us to turn it into the conditional and then turn it into the converse. Okay, so here's our conditional and here's our converse. Okay. So again, the whole idea of what we're doing here is we're basically getting rid of this if and only if. Okay, and then we need to stick an if and then in this sentence. Okay, so I'm going to write that out. If array is an angle bisector, so if an array is an angle bisector, I have my comma. I'm not writing if and only if, and now I'm going to write then. It divides an angle into two congruent angles. Okay. Again, the conditional, the second conditional or the converse of that just means I need to switch the first and last part of the sentence. Again, one key thing that we need to pay attention to here is if I go to switch the sentence, I don't want to start my sentence with if it divides an angle, because then that it, you don't know what I'm referring to. So I don't want to start the sentence with a vague word like that. So this subject of the sentence, a ray, I can keep at the beginning of the sentence, and it's just that main information is what I'm flipping. So I'm going to start this off and say, if a ray divides an angle into two congruent angles, then it is an angle bisector. So now I can use the word it's because I've already put a ray towards the beginning. You know what I'm referring to now. Then it is an angle bisector. Okay, so now we can go ahead and move that up. And now we're kind of switching gears a little bit. We're going to talk about what a good definition is. So in this box it says, undefined terms such as point, line, and plane are understood intuitively and then are used to define other terms such as segment. A good definition can help you identify or classify an object. So good definitions have the following important components. It usually is clearly understood. Oops, I missed a letter here. Okay, it uses clearly understood terms, commonly understood or already defined. It is precise. And it avoids words like large, sort of, and almost, which are kind of vague words. And it is reversible. Okay, it can be written as a true biconditional, meaning if I read the statement one way and I reverse it and read the converse of it, then they are both true. Okay, so let's look at some examples here. So in example 3, it says, explain why the following are either good or bad definitions. So what I would like you to do first before we start going over it is I want you to read A, B, C, and D. And I just want you to put a G or a B by each of those statements of if you think it's a good or a bad definition. And kind of keep in mind the 3 statements we just went over that we want to make sure it's clearly understood. We want to make sure the words are precise and it avoids vague words. And that it's reversible. If you read the statement one way, it's true. And if you read the converse of that statement, that it's still also true and only fits that one thing. Okay, so go ahead and do that. Okay, and welcome back. Hopefully you just tried that. And then now, as we talk through it, see if you were right with your first initial thoughts. If not, just fix it. No big deal. So a fish is an animal that swims. And I would consider that a bad definition. Okay, and the reason why is that one reason why is that it's not reversible. Okay, if I read the converse of that, I would say an animal that swims is a fish. Okay, so again, a fish does swim, but if I just say an animal that swims basically must be a fish, that's not very good because there are other things that swim, other animals that swim that are not a fish. So one way I like to think of this is a counterexample. Okay, and some people might throw out some counterexamples like a whale or even a dog. A dog knows how to swim, so, and you might think of other examples as well. Okay, on B, giraffes are animals with very long necks. Okay, so again, if you think if that's good or bad, I would consider that one also to be a bad definition. Okay, at first you might think, well, giraffes have very long necks. They're the only thing that has a very long neck. But very long is not very precise. So it's just not precise enough. It's kind of vague. And it is not reversible. Okay, because if I say animals with very long necks are giraffes, then again, there are other animals that have long necks that are not giraffes. So some counterexamples, I'm just going to write CE for counterexample. If you try and think of some counterexamples, one I have down here is an ostrich that sometimes people will say. So ostriches, and another one would be flamingos, sometimes people will say. Okay, and you may think of some others as well. This doesn't look too great here. Okay, Then on C, it says rectangles have four corners. Again, I would consider that to be a bad definition as well. The word corners is not super clearly defined. And also, if I do the reverse of that, if a figure has four corners, then it is a rectangle. Then again, that's just not very precise. Okay, so I'm going to say not reversible again. And again, technically all quadrilaterals, all four-sided figures have four corners, but not all of them are rectangles. So, for some counterexamples, I could say, a rhombus, or I could say a trapezoid, and you may think of some other ones as well. Okay. Now on D, it says a penny is a coin worth 1 cent. If I read the reverse of that, a coin worth 1 cent is a penny. That is a good definition. It is reversible. All the terms are clearly defined and precise. There's not anything else I can think of that's a coin that's worth 1 cent that's something other than a penny. Okay. Yes, there are other coins from other countries that might have a 1 on them, but they wouldn't be considered a cent. They would have, a different name to it. Okay. All right, last little bit here. On example 4, it says, write the following statements as a conditional, its converse, and if true, as a biconditional. So here it says, a figure is a quadrilateral with exactly 4 sides. Is the following definition reversible? So we want to start with writing the conditional, which is just an if-then statement. And again, this first part of the sentence is my hypothesis, my P. This last part of the sentence is my Q. If I need to add some words in there to make it make sense, that is fine. So I can say if a figure is a quadrilateral, then it has exactly 4 sides. All right. Then I need to think if that's a true or false statement. So a figure is a quadrilateral, and it has exactly 4 sides. Yes, that is a true statement. Okay, the converse is if Q then P. And I'm just going to say, again, I don't want to say if it has exactly 4 sides. I don't want to start with my sentence with it, but I can use that same subject figure. So if a figure, now I'm going to go to the last part of the sentence, has exactly 4 sides. Then it is a quadrilateral. And again, that is a true statement as well. And so now, because the conditional and the converse are both true, then we're allowed to write the true biconditional. That is P double arrow Q. And again, to do that, I'm just going to take the if and then out of one of the sentences and put if and only if in the middle. It technically doesn't matter if I use the conditional or the converse to do that. I usually just go to the conditional. So I'm taking the if out, and I'm going to say a figure is a quadrilateral if and only if it has exactly 4 sides. And again, that's our conditional. I think that's it. So thanks for joining, and feel free to let me know if you have any questions.